Hi, my name is Stefanie Hall, and I'm with Forest Valley Outdoor Education Center, speaking to you here from the Spruce Bog Trail in Algonquin Park. I'd like to take a moment to recognize the traditional territory of the Algonquin people and recognize the enduring presence of all First Nations, Métis, and Inuit peoples here and across Turtle Island. Today I'm here to hopefully help bring your virtual classroom to life by taking you on a walk through this trail, which is a really incredible and unique ecosystem here in Ontario and even in Algonquin Park. Some of the plants, the animals, and the bird and mammal insect species that reside here are specially adapted to be able to exist in this area. This area, when the glaciers first retreated, over 11,000 years ago, would have been an open lake, a big body of water. And through the creation of a glacial lake and then repeated impacts of beavers damming the area, the bedrock in this area is sand and gravel and then logs that the beavers would have placed and allowed to sink at the bottom of this area. Around the edges, after this glacial period, there is a special sedge that grows, and it doesn't need to root in soil, it can root in water. So those started to grow around the outer edges. And as those started to decompose and decay, they would fall to the bottom and they would start to create a layer of peat. Finally, once the area started to get populated by other grasses and other plants, they would have started to grow, and the mat of the plants would have started to meet the mat of the moss on the bottom, creating this really unique and interesting spot. So part of the bog is made up by the trees and plants in the marshy soil that you'll see at the back of the screen here, and at the front is actually a pond that is frozen. And some of the principles of the way that water freezes allows a lot of hibernation to happen underneath the water. So fish, turtles, and frogs will bury themselves deep into the water or into the bottom of the benthic layer to keep warm and unfrozen throughout the winter. The properties of water and the way that water freezes and the way it behaves between 0 and 4 degrees Celsius make this possible. So if we understand that the way that water freezes is that the molecules are coming together, there's less energy between the molecules, and therefore making them more dense and contracting, then this follows, what we understand about the freezing process. Water, however, when it is between 4 degrees and 0 degrees, does something unique. It's an anomalous process that describes the way that the water actually expands. And because it does this, because the molecules move further apart and therefore less dense, allows for a layer of ice to maintain at the top of the water, because if it was more dense, then the ice would freeze and it would continually freeze, and the whole pond would then be frozen, not allowing any of the wildlife to hibernate underneath the water. However, because of this anomalous process, which is an unusual process, would allow for all of those creatures to maintain their body temperatures at a survivable rate below the ice and a layer of ice at the top. So this forest ecosystem is dominated by the trees black spruce and tamarack larch. And the unique features that allow these trees to be very successful in this ecosystem are their ability to live in very nutrient poor. So this area, because of the high acidity in the peat and in the boggy soil here restricts the availability of nitrogen and calcium and phosphorus made available to the plants. But these trees are very well adapted to grow without a lot of those nutrients. And one of the ways that they are able to do that is by keeping their needles for many years and not shedding them. You can also see here in this example that the trees can actually bend to withstand the weight of heavy snow, and they grow very slowly. So a small black spruce could be 30 or 40 years old. So something that's just about my height here. You can see other pines and other trees that are dispersed throughout this ecosystem, but this is certainly, the black spruce is the dominant tree. As you go further north and as the boreal forest expands into more solid ground, the black spruce is also one of the most commercially extracted sources for pulp and paper in the north. It is adaptable to a multitude of conditions, which makes it so successful here. So this is the beautiful black spruce. And you can see that the structure and the shape of the bark is a perfect place for our friends, the Canada jay, to stash their food.
The Canada jay is a year-round resident to Algonquin Park, and this is the southern end of its range.
So what the Canada jay will do is it will grab the food that it will eat, which could include berries. It could include berries. We have a chickadee friend here. Seeds. They'll eat insects. They'll eat spiders. And they'll wrap the food cache in its sticky saliva, and they'll tuck it behind one of these areas in the tree. And then in the winter, when food becomes less available, they'll come out and they will, using their fantastic memory, they will remember where they have stashed their food. So one of the reasons why the Canada jay is an indicator species for climate change is due to this behavior itself. With a changing climate, the Canada jay's food caches are being frozen and thawed and frozen and thawed, and when they come back for them, not available, or they've rotted because of the thawing events. So Canada jays in Algonquin Park are actually at the southernmost part of their range, and if this warming continues, they will have no choice but to not reside here in Algonquin. They'll have to move further north. Another plant that does exceptionally well in a nutrient-poor environment is this one that we're looking at here. This plant is called Labrador Tea, and it's actually growing beside one of its lookalikes, which is over here, which is actually called sheep's laurel, which has very different features, but both are adapted to this ecosystem because despite the fact that they are deciduous shrubs, they're hanging onto their leaves for as long as they can because the leaves require a lot of nitrogen to be made in the spring, and that is one of the nutrients that's very, very scarce in this ecosystem. So if you look at the underside of the Labrador tea, you're going to see that it has a very interesting and downy underside, which some birds, including hummingbirds, would use to make their nest. And one of the properties of this downy underside of the plant is antimicrobial, and it repels mites and other insects. So interestingly, when hummingbirds use this plant to make their nests, they are protecting themselves against potential disastrous mites that could reduce their populations and have had over the last couple of decades. You can also notice here that the Labrador Tea has sort of a upside down kayak shape, and the down on the underside alongside this shape is very similar to some of the plant adaptations that one might find in the driest deserts, which is a very interesting adaptation for a wetland. However, when you think about sort of the physiology and the seasonal change of the plant, you might start to understand why it would have desert-like features to protect it. So you can see that throughout this stretch of the forest, there is a lot of Labrador tea, and it's just starting to be covered up by snow. However, it won't be fully covered by snow for a while, if at all. So the leaves are always exposed, and in certain times of the year, while the water availability is frozen, so in the late fall and the early spring, and the leaves are still exposed, there's still the potential for transpiration or water loss in the plant. So the water saving adaptations of the down underneath and the conical shape and sort of the waxy top is an adaptation to allow this plant to survive in this ecosystem when the roots are frozen and it can't access water while it still can transpire and lose water through its leaves. So the beautiful Labrador tea also has great cultural importance to the first peoples who called this territory home, including the Algonquin people. And according to Joseph Pitawanakat in the Creator's Garden blog, he discusses the properties of Labrador tea as not only being a very palatable and delicious tea to drink when you dry the leaves and brew them into a tea, but it also has the potential to reduce your blood pressure, to reduce the blood glucose in the system, akin to the power of it of what you would get if you were to do up to a 4-day fast. And it also has the potential to destroy cancer cells, and that research is ongoing. It is starting to look like it could be just slightly less effective than chemotherapy treatment, but also it is something that you can take much more frequently. So a very powerful and a very interesting, beautiful, and well-adapted plant to this bog ecosystem.